So I'm here to talk to you a bit about Redis. A little too loud. Okay. I was kind of a latecomer to Redis. I went to it almost by necessity. I have a company called Do Props, I'm representing with my t-shirt here, and kind of give you a glimpse of what it looks like. It's, and I'm not showing you this to plug it or anything, I'm just basically want to talk about it in the context of the talk. It's an activity stream, and it's pretty common in most apps today to have some sort of activity stream. So things are kind of going on as the day progresses, and we have to show them. So back in October or November, we had a publicity event. Basically, we were mentioned and got some really good word of mouth. And my original strategy, if you will, or probably more accurate to call it a tactic, was basically don't prematurely optimize anything. So the app was architected in such a way that it was just using straight SQL to display these event streams. And as soon as we started getting hundreds and then thousands of users on the site, that fell down and went badly really quickly. Even adding in the indexes and stuff didn't work. So we needed to go to a situation that would scale. And that turned me on to Redis, and the more that I started using it, the more I started realizing, okay, this can make our application development a lot more fun. So first of all, what is Redis? I think the closest thing I can compare it to is kind of like a memcache. It's a big hash in the sky as far as your app is concerned, and it's a key value store, but it's a key value store that has very rich functionality as far as the basic operations. It's really easy to set up, and it's really easy to get going with it. I've kind of pulled out a little bit of the documentation here. The documentation for Redis, as far as the commands go, is really excellent at Redis.io. So just get and set are your basic operations, but I think this presents a good example of how they've taken the basic stuff and enhanced it with functionality that makes it really, really interesting and really can spur, at least for me, has spurred my creativity when it comes to the things I'll do. So for instance, right below get, can everyone see that okay? Hopefully it's not too bad. All right, so get bit returns the bit value at an offset in the string value stored at keys. So right away, that can kind of get your creative juices flowing a little bit. You go, well, what if I started storing like bit masks and things like that in the database? So it gives you highly optimized operations for that sort of thing. My example code is at github.com/ob-redis on Rails. And I'm doing something a little different with this talk. Like a lot of times you go to these kinds of talks, you're wanting to get turned on to a particular technology, and the speaker just kind of talks at you and shows you slides with bullets and things and says, you know, this is why it's cool, and then go figure it out yourself. What's here at Redis on Rails is an example of different usage scenarios with Redis that I think is could be an interesting foundation for projects that you want to be playing around with. My colleague Kay was saying, you could basically turn this into a social network or whatever. Anyone still building social networks and Twitter clones and things like that? I mean, that's still kind of interesting, right? It was interesting certainly a few years ago, but still presents. I just seem to find that a lot of startups are replicating this kind of functionality, so it seemed pretty useful. So I'm going to try to do some live coding, and in actuality, most of the code is already written, and what I'm going to give you is like a tour through the app. But some of the things we're going to cover, as promised in the description, adding Redis-based flags and other properties, event tracking. And some of you at least have your laptops open and stuff. I think it's really helpful to kind of see the example in action. So what I was hoping to do, and I've been testing this out a little bit over the last couple days, is I'm going to open up a local tunnel. The local tunnel gem, by the way, is really awesome. It's made by Twilio. Let me just make this a bit bigger. All right. And assuming that the network is working correctly, which is not necessarily a safe assumption. Okay, so for bjc.localtunnel.com, that will actually hit my development machine here. And I have this sample app running. This is a crazy experiment. I don't know if it's going to work, but and you'll see activities start happening back here. So let's see what's going on. Yep, there goes my server. So at least some of you are logging in. Make this a little smaller. Okay. And one of the things that was a pleasant surprise as I was running these experiments, obviously I have an NSelect problem here somewhere, but it's executing pretty fast. In fact, last night I tweeted it and got slammed, and most of the pages were executing in 20 to 30 milliseconds. This is if you go look at the example code, you'll see it's kind of a Rails 3.2.2 app, the latest stuff. And I got to say, I've been very positively impressed with the capabilities of it. And if I flip over to the sample app, you'll see some of the activities here. Basically, I just modeled some conferences, kind of like a lanyard kind of thing. That's where I grabbed some of the list of these conferences. So as you click through the site, you can see who's registered as an attendee. You can unregister, and then I can register back in again. And I can look at someone's profile, for instance, my colleague Kay. He's registered for Aloha Ruby Conference. I can go to one of these conferences and I can store some notes. These are my notes. I'll add some more. Just saves it. And as you're doing this stuff, if you're playing along, you'll notice that the activity stream is updating here. Okay, so pretty straightforward, easy to understand. And what I'm going to do is, going step by step through the major categories of Redis commands, I'll just dive into this code base and show you some patterns for how to leverage them in your app. Incidentally, before I get too much into the code, you're going to see, I should talk about keys a bit. First of all, just so I can know what pace to go at, raise your hand if you've never done anything with Redis at all. Okay, it's a fairly significant part of the crowd. So I'll go into some basics. When you're dealing with Redis, and probably any key value store for that matter, there's a lot of importance in your keys. There's a lot of importance in how you generate the keys that you're going to use to store your data in the data set. So if you picture Redis as a really big hash, and it's basically flat, the way that you construct your keys so that they make sense and they're easy to actually look up the data that you put in there is pretty important. And you don't want to reinvent the wheel when it comes to doing this. I suspect it's pretty common to reinvent the wheel. Like, first thing I did was come up with algorithms for generating my namespace. You don't actually have to do that. My recommendation is to use this library called Nest. It's a really, really simple bit of code. In fact, it's so simple, I'm going to show you the source code on the next slide. But it creates a Redis connection for you by default. That Redis connection is super easy to set up and use. And it calls 2S for key representation. I'm going to talk to you in a second about why you want to do probably something different. This is such simple code that you want to hack it for your needs. This is actually the code. I know it's a little dark, but it's 36 lines, and it doesn't even really have to be 36 lines. They could have used method missing to just proxy the Redis commands over to the Redis library itself, but they chose to, put in the methods there. And what it's doing is making it transparent to be able to invoke commands on Redis while having a namespace. There is a library called Redis Namespace made by Chris Wainsrath from GitHub, defunct. And a lot of examples out there use Redis Namespace. I actually use Redis Namespace myself on some projects, but I don't recommend it compared to Nest just because of the simplicity of it. So to give you an example of why I say you might want to hack it, if I bring up my Redis initializer here. Hopefully that's all right to see. So this is in my config initializers, and this first step you're going to have to do if you want to use Redis in your Rails project is to set up a Redis connection. And I'm not going to go into how to install Redis and all that stuff. It's really, really, really easy to set up. No big deal. But basically, I got a Redis running at port 999, which is not the default port, because I didn't want to mess with my development environment for my day-to-day project. And I've taken Nest and I've actually monkey patched it to do what I wanted to do. And it's such a simple class that I didn't feel guilty doing this at all. And what's going to happen is that it's going to generate keys based on 2 param instead of 2 string. So if I pop on over to a console here, so can everyone see that? Is it okay? All right. I'll make it a little bigger. So nest.new, it just extends string. So let's say my namespace is foo. So it just returns foo. I'm going to save that to, say, a key. Now what it implements the square brackets. So let's say foo has people property or something like that. I do key people, it returns foo people. Colons are a common delimiter in Redis. And then you can just continue chaining other stuff along. When we get into the other code, I'll explain to you why I didn't necessarily want it to call 2s. But let's see, what do I have next on the slides? Yep. Okay. So, like I said, I've organized the talk into the Redis data types. The number one thing you can do is just get and set string values. And it's pretty common to do so. So how did I get and set string values in this particular app, which some of you might still be kind of poking around in? Let's go over to my TextMate just because it's easier to navigate around. And if I go to conference, conference is a regular active record class. So I can just add conferences and there's a name attribute for it. But let's say I wanted to add a location. Well, I could declare an attribute accessor location. And then I could just put getters and setters. And the getters and setters would go directly to Redis. RDB location get, RDB location set. One of the first things I do when I'm starting to use Redis is put some consistent way of accessing the database into my models. So I'll just open up base extensions. So here we go. Just another config initializer. I want to make sure that all of my active record classes have some sort of namespace way to access Redis. So I go ahead and ignore this for a second. That was just for the example app. But I'm going to create an RDB method that returns, like I showed before, a new nest key namespace. And then the key namespace is going to be self-class name to param. So if I just go back to the console and illustrate this, let's just say C equals conference first. It's a public method, so of CRDB. It just returns a string. That string is the key. So basically, whenever I put anything in the Redis key store related to this particular conference instance, it's going to be prefixed with conference 8. And then let's say I want to put a value of, for this particular conference, let's say the capacity. So that's going to be my key for conference 8 capacity, and I'm just going to say it equals, or rather, .set, which is the Redis command, and I'm going to set that key to 50. Redis says, OK, it set it. So now if I just go back and say get, I get back 50. The Redis library that maps your Ruby to Redis, basically turns everything into strings, so everything you get back is strings. You can set it to 50 and do a get again. Part of what I'm trying to illustrate here is that this can be anything. So break even point, set, $4,000, something like that. So you can just keep setting them. This happens within here, let's see, within the conference class, there it is, RDB location set, RDB location get. One of the things that you may start noticing as I go through these examples, it's actually, these sorts of patterns lend themselves to metaprogramming quite well. And before the end of the talk, I'm going to point you at some other libraries that kind of take this and make it so that it's not so verbose to do these things. So that's getting and setting values, and that's pretty straightforward and pretty boring. So let's go back to Keynote, and what else do we have? We have sets. So some of the most interesting things you can do with Redis is sets and set operations. So intersections of sets, unions of sets, usually of keys. I actually like enhancing, I don't like everything in Redis. Like, there's a library called Ohm, which lets you do object mapping and put all of your objects in Redis and kind of use that as your main database. I don't like that. There's too many things that you have in Rails that are just really, really easy if you're using Active Record. But as you're modeling your app and you get comfortable with some of these techniques, what you'll find, if you're like me, is that you start thinking about, well, there's all this extra data that we shove into our Postgres or shove into our relational stores that we don't need to project ever. We don't need to report on things that are just purely data attributes for the location of I don't know. I can't think of a good example off the top of my head. But the fact is SQL's made for reporting and aggregation and summations and things like that, for pivoting data around. There's so much stuff in your common web app that has nothing to do with those needs. But you have to jump through hoops to put them in migrations, and then, oh no, the limit on that size was no good, all right, and text fields and whatnot. And Redis is super, super fast. You don't have, when you start using Redis to annotate your active record models, you'll find that your performance goes up because you're not larding your active record objects with a bunch of extra data that's just going to bog everything down when it comes to reading it out of the database. You actually make it leaner. Just notice the friend. So anyway, these are some of the operations you have with set. The most common ones are actually at the top. So sadd lets you add a particular member to a set. smembers gives you all of the members of a set. scard gives you the number of members in a set. So let's just play around with that a little bit. Let's say I still have my conference reference hanging around. So say for some reason I want to keep user IDs. And actually, before I go down too far that road, this is such an ADD talk. I'm an ADD person. So I'm going to cancel out of here. I'm going to show you a trick for debugging. So a lot of times you want to know what's actually coming in and out of Redis. And I understand this at the bottom of the screen, and some of you might not be able to see it. I'll just bring it up here. Redis has a command line interface, Redis CLI. I'm not using the default port, so I'm going to tell it to look at 999. Now I have a command line interface into Redis, kind of like how I would have a SQL command line interface. And I can say, remember we were putting, let's see, conference 8. Yeah, so let's see, conference 8 capacity. I'm just going to show you what it looks like in straight Redis. There you go. So that's just me talking Redis, commands directly to Redis. Now, one of the neatest features that I've found with this is that you can say monitor. When you say monitor, it goes into a mode, Is someone on the website? Anyone? It's got yeah, there you go. So when you type monitor, it starts spitting out everything that it gets. And the nice thing is that as stuff is happening, you can inspect it and get an idea of, okay, that's what that Ruby code that I typed is doing in Redis. And it can help you figure out what you're doing wrong if you're stuck. So I'm just going to leave this going here. And we were starting to talk about sets. So let me just clear here and say, so I still have my conference around. I'm going to say conference RDB to get my Redis instance with the keys. So user IDs, S members. Redis doesn't care if there's nothing there. I hadn't created a user ID set or anything like that. I don't have to declare anything at first. I just said, hey, for this key user IDs, what are the members there? So I'm just going to clear here and do it one more time. There you go. So S members, conference 8 user IDs. So I want to add some to that. So I'm saying I'm going to add one. Let's see. I'll add 1, 2, 3. I can do members again, 1, 2, 3. It's pretty straightforward, easy to understand. Some of the other commands available, let's see. scard, the number of members in a set. I have 3. Sorry for the blue text there. So going back to the sample application, in this case, the attendees to the conference, attendees another active record class. It's something I want to store in my database, I want to report on. But the relationship between conference and attendees, if I wanted to model it through active record, would require a join table, because it's a many-to-many relationship. However, if I use a set directly on conference, then every particular conference instance can have its own set of attendees. And that's exactly what I've done here. So we'll look at the register class, or rather the register method. So if I want to register an attendee, see it's pretty straightforward. I take an attendee, and then I add it to the set of attendee IDs. Ignore that part for now. Just make that go away. So the this is basically the pretty easy to understand. Then if I want to get the attendees out, I do a find all by ID, and I get the members out. That will translate into an active record in query. So for instance, if I do c.attendees here, I'm going to get all the attendees that were at that conference, and you see that the query that's happening is a select where in. In this sense, what I find that it helps to think of Redis in this role to your active record models is you're basically creating indexes outside of your database. So you have specific indexes in mind. It can be like a straightforward many-to-many relationship like this, or it can be other reasons that you need indexes to that data that you want to keep around. And I find that having them in your code where you're going to use them directly is a lot easier to maintain, a lot easier to think about than having to think about, well, I'm going to actually create this index in Postgres and it's going to map to these particular fields, and there's a join involved and all this stuff, and now we got to materialize views and go down that rat hole. I'm not a DBA. I'm not an expert in database technologies. I'm an expert in Ruby stuff, and coding. I like to have this stuff close to me. These kind of techniques are not necessarily going to make you deep and lasting friendships with your DBAs and other people whose jobs depend on having complexity on the data side of the equation. But if you're in a situation where you can have agility and make your own decisions about how you architect, then these are worth looking into. Okay, so I've gotten the attendees, and that pretty much covers sets. And we'll, let's see, go back. And sorted sets. These are a little tricky. Basically, a sorted set is kind of like a hash in that for every value that's in the set, there's a almost like a key associated with it, but in Redis parlance, it's a score. And what the score allows you to do is to sort that set in different orders. So I use these primarily for activity streams, because activity streams you generally want to be able to cut off at different time periods, or you want to be able to very quickly show in descending order. So in our sample application, we have an event system. Here's our event class. And whenever something significant happens in the app, just to remind you, I'm going to flip back to the app so that these are the items I'm talking about here. Each one of these line items here is an event instance in active record. And whenever something happens in the application, I'm creating an instance of this active record class. So I do have a table called events. And after it's created, I push the event to the feeds. So I have a straight up just events in the root namespace of my app called events, and the score that I pass it is an integer representation of the timestamp of created at. And that's going to make sure that as these IDs of events get pushed into this events set, that they're ordered in the direction that I want them to be. The actual, if I go to Redis, zadd, which is the method I'm using, you see that the first thing is a key, then a score, then a member, and you can actually push more as well at one time, but generally you don't do that. So as we create events, and then this is one of the reasons I was kind of happy to put that example code out there, because it's a little more complicated than I can probably go into concisely in the talk. But this is a case where I find that single table inheritance works really well. Essentially, you can have a base event, and then you can use inheritance to model the different kinds of events in your system. So for instance, if I start walking down this hierarchy of events, you'll see that in this event folder under my models, let me just open that up a little more. I have different kinds of events that are happening in my application. So for instance, a follow event, or actually let me pick, let's see, attendee conference event. So an attendee conference event extends event, and it's going to enhance just the basic behavior of event by adding accessors for an attendee in a conference. Because whenever I'm doing something with this event, like for instance, displaying it in the app, let me just go back to one I haven't registered. So Rocky Mountain Ruby, I'm going to say register. I just created one of those events on the back end. And eventually, I'm going to want to be able to put a link to Obi and Mountain Ruby here. If I only had a text description, which is the field, the single field on the event, I wouldn't be able to do that. But with STI, basically at each level of subclass, I can put in specifically the attributes that I need. And that way, I don't have to have a big pool of attributes or a wide list of columns on my events table representing all the different scenarios for how I'm going to use it. And then these callbacks, basically I override push to feeds. I do want the parent behavior, so I call super. I just want this push to the normal feed. But I also want to push it to a couple of extra feeds. I want to push it to feeds for the attendees events, and I want to push it to feeds for the conference events. So going back just to review what I was saying before, you're creating these indexes is essentially what all these are. you could theoretically create these in Postgres, but then you wouldn't, they'd be somewhere else and you wouldn't be thinking about them. I just find that it mucks up my development process. I like to see in front of my face, this is what I'm working with. So if I ever need to know, okay, how can I quickly reference the events belonging to a particular attendee? Well, I know that I have a sorted set of events related to an attendee or conference. Am I going at a good pace? It's okay? Yeah, nods all around, good. And then very important here, okay, so I'm not going to get into this quite yet because it's a hash, but it's coming up next. Let me just flip back over. So the last data type that I'm going to talk about is a hash. And to illustrate this, I'm going to jump right back into that event class. So you notice that here, I want to have two references to a particular attendee conference event. So if I just go to my console again and say attendee conference event dot last, just get whichever the last one is, assign that to a variable, and I say a attendee. So there's the attendee associated with that event, and here's the conference. So basically just references of that object. So how does that work? Well, essentially I've set up accessors for them so that when I create this attendee conference event, which I do, this is actually a base class. So when I create one of these events, so let's just go to where the registration happens, which would be the conference class. So attendee registered event is a type of attendee conference event. You see that I'm passing in to the constructor an attendee and a conference. So what's actually happening is that since this is an active record class, the behavior that it has for the initializer is that it will call the attribute writers. Let's just close some windows here. So it's going to call the attribute writers for these particular instances that I passed in. And those are just going to get set as instance variables. Now, after the create, we're going to save the details. And the details, let's see. Yeah. So after create, I have an after create callback here in the base class, which will save details. The base class doesn't have any additional details, so it's just a no-op. And I'm overriding this. And some of you are surely looking at this stuff and going, okay, yeah, this is like basic OO stuff. When Klabnik and whatnot, talks about using OO in your Rails code, surely this is some of the stuff he's talking about. This is like taking it a step beyond just the normal Rails practices. But basically, I'm overriding save details so that it has a specific behavior relevant to this class. And I'm using this hmset command. hmset is Redis's hash multiple set. So I'm setting multiple hash key values associated with a particular key in Redis. It's a lot of hash and key words flying around. It's actually not that hard to understand. When let's say I'm just going to call save details on this thing, I still have my event floating around, right? So I'm going to clear this. Let's say a send save details. And then you see what's actually happening under the covers is an hmset, attendee unregistered event 43. That's the key of that particular value that we've stored in Redis. The value is itself a hash. The hash is attendee ID 1, hey, and conference ID 6. So then later on, when I'm trying to read those values back, those references, I can just load them lazily. So either I have a reference already stored in the instance variable to that, or I'm going to go and find it by ID, and the ID is going to reference the details hash with a particular key that's associated with it. The details method You see here, also memoizes, but basically all it's doing is a get all. Get all returns all of the hash values associated with that particular key. So that's just going to bring me back all of the attributes associated with that particular record. So go back here, the memoizes. So some of the gotchas that I've just noted to myself here, you might kind of naively do this due to your Rails background. Rails hashes are hashes within different access, so you can commonly refer to things with either a symbol or a string. This is a very common way to be scratching your head and going WTF. And that's where having the debugging kind of helps out. You pass it and you realize, okay. In this case, the hash that you get back from details is not a hash within different access, so you can't use a symbol there instead. How am I doing on time? Anyone know? Okay. All right. So that's the hash stuff. What I've done, as I alluded to in the beginning, like some of this stuff is pretty straightforward, and as you're looking at it, some patterns jump out at you where there's kind of consistent usage patterns. So if you're setting a property, for instance, you're going to do a set, and then you're going to do a get, and it's very verbose. So Kay and I extracted this library actually from doprops called Redis props. So in its infancy, like 0.1 alpha or whatever, but what it's allowing us to do is to just easily put annotations on objects. So I'll show you an example of what that looks like. The way that you're authenticating to the app right now, if you're using it, is using OmniAuth, and I don't want to get too far off on a tangent, but essentially I've created a class to represent a Google authentication. That Google authentication is just finding or creating by email, and if it can't find you by email, it just creates a new authentication with your email. Now, if you know anything about OAuth, you know that certain providers provide extra information. In this, with simple OpenID authentication to Google, you only get an email and a name, which I'm setting here. With other authentications like Facebook, you're actually getting a lot more. So the question becomes, okay, do I want to create a migration and add a bunch of columns that are probably going to be null half the time, representing all this extra information I get from Facebook? No, I want something easier. That easier, by the way, is not a serialized column. How many of you have tried to use Active Records serialized to kind of store extra stuff? Probably a good number of you, because it's like a basic part of Active Record that gets presented in tutorials and things. How many of you have had trouble with initializing serialized to the right hash value so that like you can just use it by default without having to set it to a hash first, and then sometimes it's null? That kind of madness has been bedeviling me like for 6 years or whatever. And I think there's a new serialized coming about, thank God. But I'll show you what it looks like with Redis props. So Facebook authentication represents when someone's authenticating via OAuth to Facebook. And in this case, I have all this extra other cool stuff that I can grab from that authentication event that's provided to me as extra information from Facebook. So what I've done is just using the Redis props, which I think we actually shorten now. And I give it a namespace. My namespace is info. That's going to match nicely with my OmniAuth info namespace for the stuff I'm coming back. And then I'm just going to define these key values that are going to be associated with this record. What this does under the scene is have metaprogramming magic to actually add accessors and writers and default values and all the things that you would expect from having an attribute macro on your class. And the result is that I just have these extra kinds of methods like auth_info nickname, auth_info email. And I know that single table inheritance, or STI, in Rails gets a lot of hate. I actually think it's wonderful for these sorts of things. Like, I don't want anything else in my application other than the Facebook authentication class to know the specific details of the things I get back from Facebook. So this STI lets me encapsulate that really nicely. So anyway, that's Redis props, and it's really simple right now. It just handles Boolean and string values. It will cast to Boolean. I'm not trying to turn it into a full-blown object mapper. I just want it to work for, you know, kind of these sorts of narrow situations. Let's see. Redis objects, I found this while I was researching for the talk. And it's somewhat similar to Redis props, but it's a lot fancier. This guy, Nate Ware, is in San Diego, a really cool guy. He wrote an awesome rant about atomicity in your app, because a lot of the common Rails patterns, especially the ones that are presented to you for active record use as a beginner, are rife with race conditions. Now, if you're a beginner, you're probably not working on super high scale apps, so it's not that big a deal. But once you start getting into like heavy usage scenarios, those things start biting you, particularly with things like counters, for instance, particularly with things like validates uniqueness of. In fact, it was mentioned in one of the keynotes here, I think. Basically, things in Rails that you don't want to use because they'll kill you. But the question of what you should use instead, a lot of times is just kind of left up in the air, you know, to the reader's discernment. Yeah, there's actually starting to be good solutions for this sort of stuff. Redis actually provides a counter that you can increment, and it will return and give you a place to execute code while that counter is valid, essentially doing a locking operation in one. And I do recommend that you go read this. It's outside of the scope of this talk. But if you're interested in this topic, go to this blog post, check it out. Check out Redis objects. I think I actually have an example in here. Yeah. So my location I just did with an attribute accessor. So let's say I got rid of that, and I got rid of this. Oop, goodbye. If I was using Redis objects pervasively throughout the app, then what I could do is include Redis objects and just say value location. Similar to Redis props, in fact, it's a lot more mature. And what they let you do is that he lets you store primitive values, quote unquote, in terms of strings, numbers, etc. And it'll cast for you and kind of do inference for the types that you're trying to put in. It also allows you, for instance, to do this, Marshall true. If you do that, when you stick an object in there, it's actually going to call Marshall dump on it, turn it into a binary representation, put it into Redis as a binary representation. I still have a few minutes, so I think I can actually try this to a conference. I was going to reload and do it, but let's see. Exit. By the way, the latest Ruby 193 with Rails is blazing. Like, if you're still suffering through like 10 to 30 seconds of startup time, you don't need to. This is like back to 2006 kind of speed. It's really, really amazing. So let me just get a conference. Yeah, so conference location. Instance of I/O needed. Oh, it's not connecting right. All right, so that's what I get for going off on a limb. Try Redis objects. It's interesting. I actually have my own fork of it that I'm going to start submitting patches back to Nate just to make it a little easier to use with Rails. But he's represented values. He's represented counters. He's even represented things like locks. So if you don't want to depend on the database locking, because row-level locking, for instance, in Postgres is very, very costly. A lot of those things you can really, really string up your team with. You can do very specific object-level locking using the semantics that are provided by locks that are abstracted in Redis objects. The reason being that Redis, as I was showing you before, has all these like awesome extra semantic methods for all the associations. So locking is like natively supported by Redis, where you can set a key and tell it to expire after a while. That means you can very easily create a mutex to control access to a particular record. Kind of wrapping up. Yep, that's pretty much all. I think we still have a few minutes. I'm happy to take some questions related to what I've covered here and then just talk about it. Yep. Just talk about it. So Redis is, the data that you put into Redis is in memory. That's why it's so blazing fast. And I mean, I cannot emphasize how fast you can get it to perform. And then it periodically dumps to a file, which is what makes it essentially a database. And then what you do is you just back it up, and you can have master slaves. There's a lot more to talk about there, but it's basically persists to a file. Yeah.
I was just wondering, like, you're using active record, and I'm assuming the things like the ID, unregistered events, that kind of stuff is in a Postgre database.
Yes.
But then other things like when, going back to your Facebook user, you're storing metadata in a separate database. Do you have any sort of, anything to say sort of about like, have some of your data is in one database, some of your data is in another database, and are your users themselves in that Postgre database, and this is just metadata, or?
Yeah, so I've kind of evolved this approach over the course of a year of doing do props. So if I was starting again from scratch and I was laying out the basic domain objects of an app, what I would decide is kind of like, what are my core entities, if you will, of the app? So user is probably a core entity, so yeah, that's going to go in the database. And then what are the other entities of the app that I'm modeling? Those are probably going to go in. And then the other stuff, which is essentially metadata, application control state, things that affect the behavior of the app that I cannot foresee needing to report on, like, hey, I need to sit down and write a query with joins and things to pull this data out. Or if I need to, I'll be able to just kind of do some process jobs afterwards that spit this out into a facts table to report on later. It feels like it's abuse of a relational database to use it as your main store when there's these other options. Ryan?
Have you ever refactored something from Redis back to your main store? That you made a bad decision that it's storing in Redis and you thought of
So the question is, have I ever refactored from Redis back into Postgres? Not yet. Not that I can think of. I can certainly see where that might be the case, maybe with some numbers or things or metrics that I'm keeping. But nowadays, I don't know if this is just because of the kind of like postmodern programming world that we live in. For instance, in do props, almost everything that you do gets fired off through Kissmetrics, into a service called Kissmetrics, which is the way that we do analysis of behavior and analysis of cohorts of groups of users of do props and like what they're doing. I don't have to query this stuff out of the database because we're like already firing off massive amounts of properties and counts and things like that into other systems. So the days of needing to have this, like all these little counts and sizes and things in your database that you're going to report on, it feels like those days are coming to a close because you're probably firing them off asynchronously to other kinds of repositories that are specifically customized. I don't know if that makes sense, but. Dave. Yeah, I had some stuff to show, but basically, it's so fast, and it's not transactional, and you're not going to there's the semantics of Redis transactions are basically use it if you have a bunch of batch writes or batch reads. If you have to read and write while you're in a transaction, it's not going to work out very well for you. So all that you do is basically add a before, to your test or your spec, so that before every example, you're just clearing it out. And there's easy ways to just grab all of the keys that are currently in Redis and just say delete and blow them all away.
Have you reached a limit where you're trying to use Redis for almost too relational stuff? If you're storing all of the potential Redis, have you put it up to a point where it's almost making more sense to just keep it all relational?
I mean, your mileage may vary. The question is, have I reached a point where it feels like too much data in Redis, kind of modeling the whole thing? What I keep coming back, what keeps me in active record land is that, like for instance, belongs to, has many relationships, or just works so well. For that matter, even has many through seems to work, really, really well. So the main reason I modeled this example app with sets and sorted sets representing some of these associations was to demonstrate, how they work. In a lot of cases, particularly if you don't have like millions and millions of rows in these association tables, it's probably fine to use the regular old Rails active record semantics. But no, I mean, I haven't run into that case yet. Yeah, the ranges, so if you're going to start playing with sorted sets, if you don't read the documentation carefully, you might think that you're able to query on score. So like get a range of scores, and like for instance, if you're working with time-based stuff, like one of the first things you're going to start, you may try to do naively is to pass a number representing the time between now and then the number before that I want to grab these events for a certain subset of time. And it won't work, and you'll sit there and you'll scratch your head like I did, probably going, okay, why doesn't this return the items that I expected? And the reason is if you read the ZEV range, range and ZREV range documentation carefully, you'll see that it's actually asking for index numbers. So when you ask for a range, you need to ask for like 0 to represent the beginning of the set, -1 to represent the ultimate item in the set, and so on and so forth. So if you need to index into particular items in that set based on score, the first thing you have to do other set operations first in order to get there. Actually, I'm just realizing I ran out of time. I didn't cover Z union and Z intersection, but if you look at the example code and you play around with the app, I encourage you to kind of get it running. It's super easy to get running. You'll see that essentially there's follow and relationships among the attendees. Just kind of show you what that looks like real quick. I mean, if you want to build a Twitter clone, this is the easiest way to do it. So there's a module called followings. You just add it into your user, and then you can establish just using sets. Basically, this attendee follows this other one, so on and so forth. And then based on that, you can just start creating sets that are specifically for a particular user, specifically for a particular event. And then using set intersection, you can say, okay, as a user, I only want to see the events relating to a conference that I'm attending. So you intersect the set of all of the conference events with the set of the events that the user's using. Yeah, so anyway, I don't want to get too far off into the weeds. There was one more question, I think. Yeah, I mean, if you're a stickler about, so the question is, have I ever seen Redis used as memcache? If you're a stickler for trying to keep your architecture simple, there's something to be said about not having too many moving parts, so you might want to actually use Redis as your main cache. I don't do that at DoProps. We actually have memcache that we use for our fragment caching and things like that. I have seen it used for that, and I understand that it works really well. Subject to certain limitations about expiration, I think. I don't know if those are resolved in the latest versions of Redis, but the answer is yes. I have seen it that way. Okay, thank you guys very much. Hopefully it was useful.